Hi, look what we have here. Differentiation of exponential functions part 2. So I was saying in the other video, the one that preceded this, when we were talking about tutorial applications and whatever, that the next video I was going to make was going to be on application of exponential functions in economics part 2. And the mistake I made in that video was that I wasn't actually referring to the application. I was referring to the differentiation of exponential functions again. But in this video, we'll be making use of partial differentiation, okay, and it's pretty simple, just the basic things that you've known before. I'm just trying to apply it in differentiating exponential functions. Okay, we are going to be doing a lot of long thing in this video, so I will try to manage the space, okay, I will ensure that you guys are able to follow up. Okay, before we proceed, if you want more of our videos, please click on the subscribe button. First, watch this video to the end, and if you think you like it, click on the like button, as well as click on the dislike button if you don't like it. But if you still really like it, just subscribe, turn on notifications, and share with as many of your friends as possible. Just let them partake of this kind of opportunity as well. Anyway, let's get back to business. So we have z is equal to this. So the question says that we should find the values of x and y, and that we should show that z is maximized or minimized at those values, at the values of x and y that we are going to get. So partial differentiation then says this is z, so we have to find zx, that is the z dx. Alright, so it might be written this way, the z. Please note that the d is slanted, so that is what is used to denote partial differentiation. You can write like this, the z dx, or just zx. I would like to go with this because I want us to manage space. So zx then is going to be equal to, the way we differentiate exponential functions basically. So e raised to the whole thing, e raised to 2x squared minus 12x minus 2xy plus y squared minus 4y. Then multiply by, since we are differentiating respect to x, so this is 2x squared, so we'll be having 2x squared will become 4x. This is 12x, will become a minus 12. We have x here, this is going to become minus 2y. Okay, so this is what we have for zx. Now let's do for zy. Zy is kind of writing the whole thing again, so we have e raised to 2x squared minus 12x minus 2xy plus y squared minus 4y, and then we differentiate with respect to y. So when we do that, we have y here, so we are left with minus 2x in this place. We have y squared here, so we differentiate that to get plus 2y, and then we have minus 4y, so we differentiate that to get a minus 4. So you can see that it's simple, right? Alright, now to get the critical point, what you have to do is to set zx and zy equal to 0. So set zx and zy equal to 0 equal to 0. So to get the critical point, so doing that, we are going to be having e raised to 2x squared minus 12x minus 2xy plus y squared minus 4y. Okay, so this into brackets 4x minus 12 minus 2y equals 0. Okay, so what that simply means from what we've been doing from our very first class on exponential functions, so all of this is equal to 0, then this is equal to 0. So when you have a plus b, and you have b and you have c plus d equals 0, so it means a plus b equals 0, c plus d equals 0. So all of this equal to 0, and basically there is no value of x and y that will set all of this equation to 0. Let me just write, because some might be seeing this particular video first on this. This might be some people's first video on this channel. So let me just try to explain what I'm trying to say. 2xy plus y squared minus 4y. So this is equal to 0, and then we have 4x minus 12 minus 2y. This then is equal to 0. Since there is no value of x and y, basically x, even if x and y were 0, such that we end up with e raised to 0, e raised to power 0 is 1, so it's not going to give us 0. So that is to tell us that there is no value of x and y that will make this equal to 0. So we leave this and then focus on this guy. So you see that it's pretty simple, right? It's kind of it's eliminating itself. So you have 4x minus 4x minus 12 minus 2y equals 0. So you can easily say 4x minus 2y equals 12, right? So that's about that. So we then set zy equal to 0, which is this. By the time we set zy equal to 0, we have the same thing back. So e raised to power 2x squared minus 12x minus 2xy plus y squared minus 4y, right? So into brackets minus 2x plus 2y minus 4 equals 0. So by extension, so since we already said this disappears, so basically this is also going to disappear. So we left with this minus 2x plus 2y minus 4 equals 0. So from here 2y equals 2x plus 4, and then y equals x plus 2. So you can just substitute the value of y here into this. Okay, so then we are going to be having 4. Let me call this equation equation 1, for example. Although we have okay, this should be the first equation 1, or let me just say this is equation 1. This is equation 2. So when we set this equal to 0, we're able to get this is equation 3, and then this is equation 4. So substitute equation 4 into equation 3. So then we'll be having 4x minus 12 minus 2. Instead of writing y, so we'll be writing this x plus 2, okay, equals 0. Okay, I think we already simplified it here. Anyway, it's going to be the same thing. So we have 4x minus 12 minus 2x minus 4 equals 0. So 4x minus 2x is 2x, minus 12 minus 4 is minus 16 equals 0. So 2x equals 16, and then x equals 8. Okay, so if x equals 8, definitely the value of y is x plus 2, so y equals 8 plus 2, and y equals 10. See, that's simple. Now let us test if this is maximized or not. If this is maximized or not. So what we have to do is we have to find the second derivative, and we call that zxx. Alright, and the second derivative of this, which we call zyy. Okay, before I proceed, the decision rule to know if this function is, to know if an exponential function, a partial exponential function, I don't know if that's the proper name I should call it, like an exponential function where you have 2 or more variables. Here we have 2 variables. So let's say an exponential function where you have 2 variables. So the decision rule to know if it is maximized or not is where you have zxx, that is the second derivative of x, multiplied by the second derivative of y, right, being greater than the cross partials zxy squared, the square of the cross partial. Now zxy is actually the same thing as zyx, and I'm going to prove that. I'm going to show that to you. So when we multiply this, whatever answer we get, if it is greater than the square of the cross partials, the function is maximized. So this is maximum, and for minimum we'll be having the reverse. Basically zxx zyy will be lesser than the cross partials zxy squared. So where I said that where zxy is the same thing as what zyx. So if we differentiate with respect to x the first time, which is we get zx, and then now differentiate zx with respect to y, so we get zxy, and you leave your answer somewhere. Then you differentiate with respect to y in the first instance, and whatever you have, like what we have here, then if you then differentiate this with respect to x, and then differentiate what you already have here with respect to y, the answers are going to be the same thing. So it doesn't matter. I'll just show that in this particular video, so that whatever it is that you are choosing, just know that you are going to be correct. You don't have to find this and then find this again. It's not necessary. So how do we find zxx? Obviously it's going to be a long thing. Alright, it's going to be a long thing. So let me wrap up the board. So just kind of know that condition. So okay, if this is zx, so we already have x equals 8, y equals 10. Okay. So zxx is going to be, we leave this, we differentiate this, so which is e2x squared, 2x squared minus 12x minus 2xy plus y squared minus 4y, right? Into bracket this, to bracket 4x minus 12 minus 2y. Actually, we now have to differentiate. We are leaving this. Okay. No, that's not what I'm supposed to write. We are leaving this and we are differentiating this, right? By the time we differentiate this with respect to x, so we have it multiplied by, it's only 4 that we have there, multiplied by 4. Okay, so plus, we then differentiate this. So first we left this and we differentiated this with respect to x. We then differentiate this with respect to x again, so we have e raised to power everything again, 2x squared minus 12x minus 2xy plus y squared minus 4y. When you differentiate that power with respect to x, right, to be having into bracket 4x minus 12 minus 2, 4x minus 12 minus 12 minus 2y. Okay, then into brackets what you have here already, 4x minus 12 minus 2y. It's like we are having it 2 times. So this is the value of zxx. Okay, so we can simplify, or we can just put the value of okay, this is the same as this, right? So you can just take this guy and this other guy. So we have like a 4, so it's going to be 4 plus this 4 plus this is same as that one, so that's a square. 4 plus 4x minus 12 minus 2y square. Okay, so all of this into bracket e raised to power 2x squared minus 12x minus 2xy plus y squared minus 4y. So I think we've been able to simplify the whole thing. So we then substitute the values of x and y that we got earlier. So here we'll be having 4 plus 4 into bracket, this is 8 minus 12 minus 2 into bracket 10 and square. Okay, alright, all of this into bracket e raised to power 2 into bracket 8 squared minus 12 into bracket 8 minus 2 into bracket 8 into bracket 10. Okay, plus 10 squared minus 4 into bracket 10. Okay, you might be wondering that why do we have all of this? So we have this is 4 plus, now 4 times 8 is 32. 32 times 32. Okay, let me just, okay, we have 4 plus 32 minus 12 minus 20. Okay, so the square is for everything outside, squared into bracket e raised to power 8 squared is 64 times 2, 128 minus 128 minus 12 times 8 is 96. So we have 128 minus 96 minus 8 times 10 is 80 times 2, 160 minus 160 plus that is 100, then minus 40, so we're having minus 68. But if you look at it, this is this squared. If you look at it, 32 minus 12 is 20, 20 minus 20 is 0. So 0 squared is 0. So we are just left with 4 on this side, e raised to power minus 68. So this is the value of our zxx. And by the time we find, so this is equal to 4 divided by e raised to power 68. And 4 divided by e raised to power 68 is going to give us 4 divided by e raised to power 68. 1.17 whatever raised to power times 10 raised to power 29. Okay, so here we'll be having 1.17 approximately times 10 raised to power minus 29. Alright, so we keep this, so we have the zx, which is zxx equals 1.17 times 10 raised to power minus 29. So we are going to look for zxx now, zyy rather. Okay, so you should be able to manage this space. So zyy is going to be, we are differentiating this guy with respect to y. So we just the way we did for this. So we leave this, then we differentiate for y. So we're having this zy, right? So we're having e raised to power 2x squared minus 12x minus 2xy plus y squared minus 4y, then we differentiate with respect to y. So that's going to give us y is here, that's going to give us minus 2x plus 2y minus 4. Okay, then plus, so we left this, we differentiated this, so we're differentiating this now. Let's say plus we have this guy again, e raised to power 2x squared minus 12x minus 2xy plus y squared minus 4y. So into brackets, when differentiated with respect to y, you have minus 2x plus 2y minus 4. Then we bring in what is just beside it, which is minus 2x plus 2y minus 4. Then close the whole bracket. So it's more or less like what we did in the first instance. So if we then look at it, we have this here. Wait, is this what we are supposed to have? So we left this, we differentiated with respect to x. So we have this, we differentiate with respect to x. I'm coming. So this is zy. We left this, and we differentiated this with respect to y, right? So we are supposed to have just 2 with respect to y. So we are not having the whole of this. We are supposed to have just 2 here. Sorry for that, just 2. Because this is 2y, so just 2. Then we leave, then we differentiate this, which is this. Alright. So if you look at it, we have this here, and then we have, it's the same thing as what we have here, but then we have this as its coefficients, and then we have this as the coefficient of the second one. Let's kind of do what we've been doing. So we have 2 plus minus 2x plus 2y minus 4 squared. So all of these belong to the same place. E raised to power 2x squared minus 12x minus 2xy plus y squared minus 4y. Right. So if you substitute the values of x and y, you're having 2 plus minus 2 into bracket 8 plus 2 into bracket 10 minus 4 close the whole thing squared, and it's going to give us e raised to power minus 68, because it's still the same thing, as it's still the same power. So 2 plus 2 times 8 is 16. This is minus 16 rather, minus 16 plus 20 minus 4 squared. Okay, e raised to power minus 68. So if you look at it, minus 16 plus 20 is minus 4, right? Minus 16 plus 20 is 4. 4 minus 4 is 0. 0 squared is 0. So we are left with 2. So this is going to be equal to 2e raised to power minus 68. Or better still, we are going to be having 2 over e raised to power 68. Let me just leave it this way up, but no problem. So let's try to get what that is going to give us. So 2 divided by e raised by 68, that's 5 points. Okay, let me do it again. 2 divided by e raised by 68. So we have 5.87 times 10 raised by minus 30. Okay, so if I want to bring it to what we have there, so that will be equal to 0.5. Okay, that will be equal to 0.58. 5.87 times 10 raised by minus 30. That should be. Okay, let me just let's leave it like this: 2 over e, and this is I think this was 4 over e raised by 68, right? So what we added was 4 over e raised by 68. If I'm not wrong, and this is 2 over e raised by 68. So now we need to go and get the partial, the cross partials. Okay, so z y y equals 2 over e raised by 68. So now you get z y x. So if you want to get z x y, for example, can you see contain here? So z x y is saying that we are going to let me rub it off. So I'll rub from here downwards. Okay. So z xy is equal to, so we have all of this, and we are going to differentiate with respect to y. The same thing, you e raised by 2x squared minus 12x minus 2xy plus y squared minus 4y. When you differentiate this with respect to y, you are going to have minus 2 into bracket minus 2. Alright, so that's minus 2 since it's y. Then plus, we then differentiate this, so we have e raised by 2x squared minus 12x minus 2xy plus y squared minus 4y. So since we are differentiating with respect to y, into brackets, y is going to give us minus 2x plus 2y minus 4 plus 2x plus 2y minus 4. Okay, so into brackets 4x minus 12 minus 2y. Let's just say we have a double bracket there. Alright, so if you look at this, so you have e here, you have what you have here, it's the same thing as what you have here. So we have a minus 2 plus minus 2x plus 2y minus 4, then 4x minus 12 minus 2y. So everything into bracket e raised by what? E raised by let me just say minus 68, since we already know it. So then we put the value, plug in the values of x and y. This is a minus 2 or just 2. This is a minus 2 here. Okay, so minus 2 plus or minus 2 into bracket 8 plus 2 into bracket 10 minus 4 into bracket 4 into bracket 8 minus 12 minus 2 into bracket 10. So everything used by minus 68. So we have minus 2 plus minus 2, this is minus 16 plus 20 minus 4. So if you look at this alone, minus 16 plus 20, that's 4, this is already 0. Alright, and here you have 4 times 8, you have 32 minus 12 minus 20, then into bracket e raised by, okay, we close all of this, into bracket e raised by minus 68. So you have minus 2 plus 0 plus 0 into bracket e raised by minus 68. Alright, and that's just going to give us minus 2 into bracket e raised by minus 68. Alright, or equals minus 2 over e raised by 68. Of course, if you look at it, so if this is zxy, and coming to look at this already, zxx is 4 over e raised by 68, and then zyy is 2 over e raised by 68. So if you look at, if you multiply that, so we'll be having 4 times 2, that's 8, right? So 8 over e raised to power 68 times 2 is 16136 or so. So that will be 8 over e raised to power 136. Okay, and that's obviously, that's going to be positive. This one too is going to be positive anyway. But you can't compare the value that you'll be having here with the value that you're going to be having here. But let's see. So now let's verify for z, y, x to see if we are going to get this. You don't need to do it. What you just need is to get either zxy or zyx. But I'm going to do it so that by the time you are solving it on your own, whatever it is that you've chosen to use is going to yield you the same answer. So this is zy. So let's differentiate this with respect to x. So we leave this. So we have e raised by 2x squared minus 12x minus 2xy plus y squared minus 4y. Okay, then we differentiate this with respect to x. So we are going to be having a minus 2 there. Okay, a minus 2 here. Right, then plus, let me just write it here. Plus, we've left this, we differentiated this. Then we, what's the next thing? So we leave this and then we differentiate this. So differentiating this is going to give us the same thing back, e raised by 2x squared minus 12x minus 2xy plus y squared minus 4y. Okay, then into bracket, when we differentiate this with respect to x, so we'll be having 4x because it's 2x squared minus 12 minus 2y. Right, so we are done with differentiating with respect to x, and remember that there is this beside it. So into bracket minus 2x plus 2y minus 4. Alright, so we're taking like terms. You have this minus 2 plus 4x minus 12 minus 2y, then minus 2x plus 2y minus 4. So everything into bracket e raised by what? E raised by 2x squared minus 12x minus 2xy plus y squared minus 4y. Taking a look at this already, look at what you have a minus 2 here, you had a minus 2 here, minus 2x plus 2y minus 4, it seems as what we have here, minus 2x plus 2y minus 4, then we add 4x minus 2y minus 2y here, 4x minus 2y minus 2y. So setting x equals 8 and y equals 10, obviously we are going to be having minus 2 plus 0 plus 0. Okay, this is multiplying this. Okay, let me put them properly. Okay, where did I do the first one? So this is not plus 0, so it's just plus 0. Plus, this is multiplying this, so it's just 0 like that. This is 0, this is 0, 0. Okay, so here you have 0 as well, then e raised by, by the time we put the value of x, they have minus 68. So, and then we still have our minus 2, e raised by minus 68, or minus 2 over e raised by 68. So what we have to prove, what we have to show now, if this were minimum or maximum, is we want to check if this will be greater than this or if it's going to be less than it. Zxx times zxy, so that will be 4 over e raised by 68 times 2 over e raised by 68. Okay, and this is going to give us 8 over e raised by 136. I think that's what I said the other time. 136 equals, so 8 divided by, well, let me first do 68 multiplied by 2, 136. So 8 divided by e raised by 136, that's 6.9 times 10 raised by 59 minus 59. 6.9 times 10 raised by minus 59. And then let's see what this guy is going to give us. Minus 2. Okay, minus 2 divided by e raised by 68. Okay, minus 2 divided by e raised by 68 minus 5.8. Okay, this is minus I'm supposed to square this because it is square here. So when I square it, I'll be having 4 over e raised by 136. So by the time we square, where is the answer again? Okay, we have to square this because that's what we have here. So z xy squared, so it's 4 divided by e raised to power 136, 4 divided by e raised to power 136, so that's going to be 3.45 times 10 raised to power minus 59. So if we compare the two answers, of course 6.9 is, I think, twice of this, right? 6.9 is greater than this, and that is to show that zxl is greater than this. Therefore, this function is at maximum. Because this is maximum condition, is at maximum where s equals 8 and y equals 10. So I've written the assignment. So the assignment is given z equals e raised to power 3x squared minus 6x plus y squared minus 8y. So show that the function is maximized or not. So you have to prove that if the function is maximized at whatever critical point that you get or not. Okay, basically just understand the conditions for maximum or minimum. Okay, here I wanted to rub this up, but I wanted to rub this up for the assignments, but I just decided to leave it. So here I could just say like this is z xx, in case you were writing an exam, times z y equals this. Yeah, that was what it was. And in fact, okay, it's not square. And this one, this is actually your z xy square. Okay, so just like add those things. So we've gotten to the end of this video. In the subsequent class, we're talking about logarithmic functions. You know, this is the third class on exponential functions. So we are moving on to logarithmic functions, and I would really love to see you there. Or don't you want to see me? See you in the next video. Thank you very much for watching. Bye.
Please like and subscribe.